Thank you. Yeah, I'm Timo. I work at Otto. This is a big German e-commerce platform, right? And today I want to talk about identifying offline metrics that predict online impact and give us pragmatic strategy that you could use, to identify those matrices and improve your recommendation system, right? So we start with the basic question, does my offline metric have business impact or does it impact some live KPI, right? Basically, maybe we already have a recommendation engine and we have some kind of offline metric. And we ask ourselves, is it useful? Isn't it useful? Or does it have some reward impact on KPI K? Or we might even think, okay, I want to have impact on K, on the KPI, right? So I'm going to construct a custom metric, and then how do I check if this metric makes sense or has impact? Or management comes up to you and tells you, for the next iteration, please improve KPI K. And you are like, okay, do I even have an offline proxy? And what we want to do is to give a strategy right now that you can help yourself. And it's mostly interesting for industry practitioners. Okay, let's start with a very, very simple idea, right? Let's just assume that we can say, we want to have G groups or split traffic into G chunks, right? And serve different models on that, right? So we have to train G models. And these models are going to have a different metric, like maybe recall at 20. So they have different recall at 20 performances. And then we just measure a KPI, for example, CTR or something. We just hope for correlation, right? Let's say we deploy 100 models simultaneously and train them. And then, maybe there's correlation, but this would be cool to visualize. And this is not pragmatic, right? Because we cannot train 100 models or 10 models and then deploy them simultaneously. So the goal of this research is to be able to detect some dependency which might look like this by just using one model, right? Okay, so, and the main idea to solve it or to get there is an idea from Pareto front approximation. Let's just assume that you have a deep recommender system with two, or with at least two objectives. In the case if you're in the case to have a single objective system, just think about adding 0 times some regularization term to your loss. Then you're basically already in a multi-objective setting. Right, and basically the simplest idea would be just to scalarize your loss according to some pi, and then just train your model, right? And then you could fix pi again, train a model again, and get another model, choose a different pi and do it again, and then you are still going to end up with multiple models, right? And what we are going to do differently right here for each batch, we are going to sample this pi according to Dirichlet distribution. In the two-dimensional case, this is equivalent to be a beta distribution. And now the trick is we use this temp sample pi at each batch and append it to the input of our recommender system and weight the losses accordingly. And what we are going to end up with is a recommender system that is conditioned on pi at inference time, which means we are going to be able to access or to control the model R through pi and to change the loss trade-off, which might induce a different offline metric accordingly. And this is the most important idea. Now the overall strategy is, we trained such kind of model where we appended pi to the input during each batch, right? And now we have the ability to deploy it and to access the whole Pareto front at inference time. Now basically the question is, okay, I've done it, I have my test set. Now I choose some offline metric, maybe, recall at 20, and choose different pi's like G pi's and iterate or do evaluation on the test set G times and end up with matrices, right? Then we are going to deploy R and split the traffic randomly into G groups. And basically then we are going to serve each group with its assigned pi and obtain data tuples like the metric which the user corresponds to and what he did in this situation. Maybe he clicked and ordered, just clicked and didn't order, or he just did nothing, right? And afterwards we obtain data and then we can just perform a regression between the metric and the observations across all samples and look if there's a statistically significant relationship, right? And yeah, this was just theory. Now we have to prove that it might work in practice, right? So we have one experiment in this session-based recommender systems domain, right, where we have sequential interaction data of users, and we have two tasks here, right? We have a click task and an order task, indicated by the upper blue items, like at times the one we try to predict the next click, which would be the click of item 2. This is a click task. And the red zeros and ones just indicate if this clicked item is ordered afterwards. So ordering after clicking, right? Okay, then we have two loss functions. We sample pi with the discussed procedure, yes. And yeah, we end up with our recommender system R, right? And now we have to choose some offline matrices we want to evaluate on our test set. And this, we are choosing them for the task, right? We have this click task, so let's just take recall to, as a hypothesis, maybe it is a good proxy for CTR, right? Then we came up with a custom offline metric, which is called order density. This is the number of successful clicks with the number of successfully ranked clicks which have been ordered divided by the number of total successful clicks. This is the proxy for the post-click CVR, and we can measure maybe measure the joint effectiveness from a user going through the funnel through the product of recall and order density, and maybe this could be a good proxy for units sold, right? So we conducted this experiment. We've chosen G to be equal to 5 from left to right. Recall is a good proxy for CTR. Order density for post-click conversion, with more variance in there because it's a low support event, right? The product metric is a good proxy for units sold because it's significant. And another interesting thing is because we're on the Pareto front, right? We have to trade recall. If we want to increase clicks, we have to give up post-click CVR, right? So it's interesting to see that recall. When we increase recall, you are losing post-click CVR, and this is in line with the understanding of the Pareto front. Now, if you want to drive units sold, there is the question, which metric should I improve, recall or order density, which is easier, and it turns out, at least for Otto, and on the Pareto front for this task, it's easier to go for clicks, because increasing recall at 20 by 1% results in a 0.9% increase in CTR, while just reducing post-click conversion by 0.2%, which ends up, at 0.7% more units sold here in H3, which is just the slope of the regression line. Yes, thank you for your attention. If you have any questions, you can ask them or contact me at LinkedIn afterwards or have a look at the code of this project. Thank you.
Do you think that the choice of objectives could impact the fidelity of the offline-online regression, or should sort of any set of objectives work?
Should we what? The second part of the question?
Or should any set of objectives work?
Well, if it doesn't work, you shouldn't see correlation as well. So then you see, it doesn't work, right? When you, I think you should choose your offline metric as a good proxy of what you want to approximate the real world. So I think, it makes sense to choose an objective that makes sense here.
It seems to me that OD at 20 is simply recall at 20, but computed on the order events instead of the click events.
Yeah, exactly. It's basically recall in the recall, right, on the click recall support. Yeah,
okay.
This is true, and you can see it in the paper. I didn't get much into detail.
Okay. Your method regresses offline metrics against online KPIs, but those relationships may shift with drift or nonlinear effects. How do you make sure the offline-online correlation remains valid over time?
I think maybe this is a technique to just find also your future direction, which offline metric you want to improve upon, right? And then you go into this direction, maybe for a few weeks or a month, right? And then maybe drift happens or whatever, but what you should observe then in your A/B tests, maybe that you cannot outperform anymore when you improve this metric, right? And then maybe you should do it again or become smarter. Yeah, so basically intuitively would make sense maybe in practice.